in stone, and I expect and hope for a quick answer. Can anyone tell us?
1 over x.
Brilliant. Thank you so much. Can anyone tell us how to differentiate natural log of f? Please, anyone? Yes?
Over f times f prime.
Brilliant. Awesome. And this one? Natural log of the absolute value of x prime. I don't have enough room there, so that's
1 over x.
That's it. Awesome. Excellent. Now, I would like us to make sure that this is also carved in stone. We have a function. We have a point, 2, 3. We have the tangent line at that point. The slope of the tangent line at P, which is m tangent P, is what? This is extremely important. This is basically the summary of what we studied so far. And this has to be clearly understood. Please. What do I put here for this situation? Please, anyone? Please, anybody? I refuse to believe that no one knows this answer. I refuse to believe that. So look at this example and tell me what to write here, please. Anyone? Anyone, please. Well, if this is not clear, then we cannot make progress. Because this is the core of what we're doing here.
Is it 3?
Careful. So this point is 2 for x, 3 for y. This is the tangent line at the graph of the function at this point. We would like to determine the slope of this tangent line. So no, it's not 3. Anyone else?
Zero?
No, it's not 0. I got 2 answers. Donnie, what do you think?
Is it a fraction?
No. We don't have 2 points. Anyone else? It's okay if you're wrong. I just need to know if this is...
it 1?
No, it cannot be 1. Okay, so let's go back to the notes from last time. I'm begging you to redo the notes. I don't mind begging you. I'm not embarrassed to beg you. I will continue begging you. I made it part of my job. But if this is not clear, we will always have difficulties in this class. So what is the slope of the tangent line to the graph of f of x for our example?
Did it say f of 3?
Careful. It cannot be of 3 because 3 is the y value.
Derivative.
Yes, the derivative of the function at
3.
3 is the y value. It cannot be, we cannot evaluate at a y value.
2.
Exactly. So please, I'm begging you, every little thing is important from the notes. Everything. Everything is important. If you do this for yourselves and for me, every time, for every class, you will have no difficulties in this class. Please, please, please. Okay, so one more time. The slope of the tangent line is the derivative evaluated at this value? So as we had it last time, it was the derivative evaluated at the x value, because this represents the rate of change of this function, the instantaneous rate of change of this function when x is 3. So that's,
So it's always gonna be the X that we use?
of course. But can we plug in f or f prime or f double prime any value but x? Do we ever plug in y? Right? We always plug in the x value. So if I want to evaluate this function, I plug in 2. If I want to evaluate it f prime, I plug in 2. I cannot plug in 3. We only plug in the x values. In the function, in the derivative, the second derivative, in any function, we never plug in the y value. We plug in the x value to get the y value, not the other way around. Is that clear for everyone? I'm going to ask this every class moving forward. Okay, enough of that. Now, what does the derivative tell us about the function? What does it tell us? Can anyone say anything? When we look at the derivative, when we study it, whatever we do to it, what does it say about the function? What do we expect to find? Anyone, please. When we determine the derivative, we do it because it tells us a lot about the function. What can we learn? By studying the derivative, what can we learn about the function? Anyone, please? Anything?
How the function changes over time,
Okay,
increases or decreases?
exactly. Increasing, decreasing intervals. Awesome. So, when is the function increasing? When the derivative does what? So the function is increasing when f prime is
Is greater than 0.
excellent. The function is decreasing when f prime is
Less than 0.
less than 0. That's number 1. Awesome. Great job. What else? What else we learn from f prime about f? They're
If
all,
f can equal 0 or it's undefined.
yes, so they're all in here. We discussed all of these. So, critical numbers. So critical numbers, because they come from f prime being 0 and or from f prime of x being undefined. If a function has critical numbers, is it guaranteed to have a max-min?
No.
No. We have to study the sign. So max-min, I don't have enough room here. So max-min are also determined by the first derivative. If f prime changes sign, as we discussed, from positive to negative or negative to positive. If it does not change sign, the critical number is not a max or a min. Okay, now we have a request to work on this problem. So we're given time function of temperature. And this is problem 32 on page 217. I'm going to copy it on the next page. And please make sure that you have your questions ready so we can address them right away. So this is problem 32 on page 217. So we have time, function of temperature, and we have the formula 250 natural log of 38 over 76 minus t. This time there was no typo. So T was anywhere between 38 degrees Fahrenheit and 76. Okay, and the time is in hours. And they want us to find T of 60. They want us to find T prime of 60. And they want us, and this is part A, and in part B, they want us to find the temperature when the time is 8. So T equals 8 hours, find the temperature. Okay, first question I have for you is, can we skip T of 60? Do we know how to punch in T of 60? If you say no, we want to see it, I'll do it. Anyone? Is T of 60 okay? Can we just move on to T prime? Is everyone with me?
I see it.
The T of 60, you mean?
Yes.
Okay, so you go to the calculator and you punch it in y equals, clear whatever you have, and you have 250, and then natural log, and 38, don't forget parentheses. The denominator has to be in parentheses, mandatory, otherwise you're not going to get what you're looking for. Close the parenthesis and close the parenthesis for the natural log, and you plug in 60, and we get whatever we get. So I got 216.25. So T of 60, 216.25 hours. Good, so we want to focus now on T prime of T. So we have 250. And remember, a natural log of a function, you already told me the formula, is 1 over the function times the function prime. So I'm going to write it like this first. 38 multiplied by 76 minus t to negative 1 prime. I don't recommend differentiating using the quotient rule if there is no variable at the top. Can you? Sure. But you have to be very careful because when you differentiate 38, you get 0. So careful how you do this with the quotient rule. I don't recommend it. But if you change it like this, which is the same thing, this will be easier. I'm going to flip here. So I have 250 times 76 minus t over 38 times negative 38, because I have to bring down 1. I'm sorry, negative 1. 76 minus t to negative 2 times the inner function prime, which is negative 1. Negative 1 with 38. We'll simplify with this 38. Then we have 250, 76 minus t. And this goes to the denominator. 76 minus t squared. You can simplify because you're simplifying factors. So the final simplified form is this. Then they're asking us to find t prime of 60. So t of 60 is in hours. But t prime of 60, remember, has to have 2 measurement units. One coming from the y variable, which is in hours, and the other one coming from the independent variables, which is degree Fahrenheit. And we have to plug in 76 in here to get t prime of 76. So I'll enter the derivative as well. So it's 250 divided by, of course, parentheses, 76 minus t. And I already have 60 in there. I just have to read from the other function. So I have 15.625. So what does this mean? It means that when the temperature is 60 degrees Fahrenheit, the rate of change of time is positive, so it's increasing. The function t is increasing because t prime is positive. It's increasing by 15.625 hours per degree. For each degree Fahrenheit, the hour goes up by 15.625. And I think, where's, what did I do? Okay, here it is. So now they want us to find the temperature when T equals 8. Oh, I already have that up there. So when T, any questions on these steps? So these are identical steps with the ones that we looked at last time. We selected another problem and we went through the same steps. So, however, this problem is also asking us to find T when lowercase t is 8 hours. Would you, this is just algebra, there is no calculus here. Do you want me to show this, yes or no?
Yes, please.
Okay, so, perfect. So, 8 hours equals 250 times natural log of 38 over 76 minus t. We know this is a logarithmic equation. How do we start? What is the first step here? We've done this before. This is just a repeat. What would be the first step? What do you recommend doing first? Anyone, please. Can anyone tell us what would you do first here? Anyone, please?
You subtract 250 on both sides.
It's multiplied. So you meant divide. So if there is no symbol between 250 and natural log, we cannot add or subtract. We have to divide. So it's 8 divided by 250 equals natural log of 38 over 76 minus t. Now remember, this is a log equation and we have to change it into an exponential one. Remember, what is the base of natural log? I don't see any base, but we know what it is. What is it? The base of natural log, please.
Is it 1?
There is no base of 1.
0.
So the base cannot be 0 or 1. The base can be, so the base can be only between 0 and 1, not 0, not 1, or the base is greater than 1. Can anyone tell us what is the base of natural log, please?
One.
There is no base of 1. There is no base of 0. It can only be positive. It cannot be negative.
Is it E?
Of course. We discussed that many times. So remember, the graphing calculator has the same key, e to the x and natural log, 10 to the x and log, because these are inverses of each other. The base of log is 10. The base of ln is e. Okay? Good. So let's continue. Now we have to change this into an exponential equation to finish it up. That's why I needed the base. The base raised to this number equals this number. So e raised to this equals this. E raised to 8 over 250 equals 38 over 76 minus t. Don't do anything, just multiply by 76 minus t. So e to 8 over 250 times 76 minus t equals 38. So we change it into a linear equation. This is just a number. Don't get thrown off by it. It's just a number. So what will be the next step to find t? This is just algebra. There is no calculus here. So what will be my next step? What do you think? It's a linear equation. What do we do next? Can anyone tell us what to do next? Yes, go ahead.
Redistribute?
You can. Yes, you can. No, it's perfect. But I would prefer getting rid of it. So 76 minus t equals 38 over this. E to 8 over 250. I divided by it. I divided both sides by e to 8 over 250. But distributing is fine. So of course I'm going to move 76. So negative t equals 38 over e to 8 over 250 minus 76. And yes, you know me, I'm allergic to negative leading coefficients. So I'm going to write 76 minus 38 over e to 8 over 250. This is not easy to enter in the graphing calculator. It's not. Not easy to enter in